The dataset chosen is about classifying mushroom into edible and poisonous category based on their characteristic. The dataset chosen was detailed via creation, curation, and simulation of a dataset for binary classification, edible non-poisonous mushroom classified via their characteristic like cap shell, keep color, odor, and more. Qualitative attribute type like cap shape and cap surface, while quantitative attribute type like stem height and cap diameter. The objective of the project is to determine the best classification model that places the distinct mushroom in edible or poisonous class with a respective behavior, characteristic, and species. The flow of the task in the project is from the dataset, the data is reprocessing, and next, the reduction that selected attributes, next, the model development usings, next, evaluations, and next, we can get the tree descriptions.
Thank you to Nur Atika binti Zulkifli. Now we proceed to data cleaning. In this data, they contain 3 numeric attributes and also 18 nominal attributes. The first step in cleaning the data, we remove a noisy data. Attribute 9, 13, 14 and also 19 were removed due to missing value and also data limitation. This attribute was removed by using filter remove. After remove the noisy data, the attribute was reduced to 17 attributes from 21 attributes. Next is we replace the missing value. By using a filter replace missing value, there are 5 attributes that will replace the missing value with the expected value. This table shows there are 2 differences between before and after we using a filter missing value. And after the process of data cleaning, this is an example of 21st row from this data.
Assalamualaikum and very good evening. Today I am Raja Farni Iza binti Raja Omar from RAS2014B. We're going to present about A3 data preparation transformation. First of all, normalization. These are the steps for normalization. Then why does we use normalized filter? Normalized filter is very useful for any attribute, especially numeric type, which it also helps in distribution and algorithm assumption of the dataset. So these are the results for before and after normalization. And then we move to discretization. These are the steps for discretization where we choose 3 bins to be implemented. Then these are the final step of discretization for 3 numeric attributes, which are attribute 2, 9 and 10. And these are the results for before and after discretization. For changing label name, we decided to do it manually. So these are before changing label name. After changing label name manually in Excel, then after we use the data into the weka, then changing label name will become short, medium and tall. And then lastly, this is the first 20 rows of sample in the data set. Thank you. For model development and evaluation, we choose classification. So these are the steps for cross-validation with different for K10 and K20. Then these are the results for K10 and K20 cross-validation. For cross-validation K10, correctly classified instances is 51.337%, while incorrectly classified instances is 48.663%. In cross-validation K20, correctly classified instances is 51.3567%, while incorrectly classified instances is 48.6433%. For percentage split 70 and 80, these are the results. Correctly classified instances for 70% percentage split is 51.138%, while incorrectly classified instances is 48.862%, while percentage split for 80, the correctly classified instances is 51.4328%, while incorrectly classified instances is 48.5672%. So Finally, these are the three visualization for both. Thank you.
So the first step of data reduction is to determine which attribute is most useful for the dataset. So first select the Attributes tab, choose Attribute Evaluator, Info Gain Attribute Evaluator. If there's an alert, click Yes, and then click Start. So the top 6 attributes are the attributes that give the most contribution to the dataset. Hence, the remaining attributes are deemed the attributes with least contribution and therefore removed. So this is how it looks like after reduction. Removing the attributes are done using the remove function in the pre-processing tab. And this is how it looks like using the viewer. Only 6 attributes remain after the reduction. As you can see, there are no changes in the value. So what we do with the reduced dataset is we run it on the J48 classifier based on the cross-validation with 10-folds and 20-folds. So for the 10-folds, the correctly classified instances are 96.4106%. The incorrectly classified instances are 3.5894%. And for the 20-folds, the correctly classified instances are 96.3975%, and the incorrectly classified instances are 3.6025%. And then we also use the percentage split, which is another option to evaluate the classifier. We use 70-30 ratio and 80-20 ratio. So for 70-30 ratio, the accuracy of it is 96.4303%, and the incorrectly classified instances are 3.5697%. And for 80-20 ratio, the correctly classified instances are 96.6104%, and the incorrectly classified instances are 3.3896%. So this is the visualization tree of the reduced dataset. So the number of leaves are 342 and the size of the tree is 381. As you can see, this is the histogram depiction of the initial dataset and the reduced dataset. So the accuracy of the initial dataset is lower compared to the reduced dataset, which means that using the reduced dataset is much more efficient.